Now usually for circuit, you have two batteries that are in series, in sequence. So you have 1.5 volts plus 1.5 volts, that's 3 volts. And then across that, you have a switch, a button switch, resistor. I think this one's about 500 ohms, and then an LED light. Now, suppose I want to measure the potential difference across the resistor. It means the voltage across the resistor. Now, I know the maximum voltage in the circuit, the maximum power is about 3 volts. So the voltage across the resistor is definitely going to be somewhere between 0 and 3 volts. So that's why I've set up my setting here to something, only have 2 volts, but I'm going to set it to 20 DC volts. And then I want to measure the voltage across the resistor. One way you can do that, obviously when you're measuring voltage, you don't have to disturb the circuit. So one way you can do that is you can come in with your leads, with your probes, and you can measure directly on the resistor itself. So I'm touching one probe on the one side of the resistor, the other probe on the other side. And if obviously right now it's not charged, there is no current that is passing through, there is no voltage across that resistor. But if I press that button and then the current starts flowing, you can read the voltage now, it's about half a volt, 0.49. By the way, obviously if I flip these, that means that I'm measuring the potential difference between the 2 points, but I'm measuring the potential difference, I'm presuming one of them is higher than the other. And when I measure now, you can see that the number is negative because it's telling me that the black lead is higher than the red one. So if I flip them back, then the red would be higher than the black, and I read the 0.5 volts.